Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight are three of our students who work at the Planetarium, and I will let them all introduce themselves, and we'll start with Jenna.
Hi, my name is Jenna, and I'm a graphic design major at UMD.
Hi, I'm Luis. I'm a chemical engineering major.
Hi, my name is Allie. I'm a biochemistry major.
Awesome. Lots of great backgrounds. Is that the right majors? I don't know. Lots of cool stuff going on at the Planetarium. All right, so since it is, I can't believe it, December 1st, I don't know, because am I the only one that feels like this? That every month I'm shocked that it's a new month already? Like, I don't know.
Not at all.
But since it is the beginning of December, tonight's show is going to be our What's Up show, where we're going to take a look at the astronomical events taking place throughout the month of December. And there's quite a bit to talk about tonight. So I'm going to quickly just jump into it. As I'm getting everything set up, as always, if you have any questions throughout the show tonight, feel free to leave them down in the comments. I almost said Eli, but you're not Eli. Louise is going to be keeping an eye on me. It will let me know as questions come up. And then we'll also have time at the end for questions as well. All right, so let's get into What's Up December edition. And we're actually going to start with a solar eclipse that's happening in just a few days on the 4th. Now, I'm going to go ahead and preface this. Unfortunately, this is not a solar eclipse that we will be able to see from anywhere here in North America, but it's still a very rare and awesome astronomical event, so I wanted to talk about it. So we had a lunar eclipse last month, and we saw that happened during the full moon when the moon passes through Earth's shadow. For a solar eclipse, we have the moon on the other side. So the moon is passing in between the Earth and the sun, and for a short time period will block the sun from our sky, or block the light from getting to us, and it'll get dark for a few minutes. Now, unlike a lunar eclipse, where anyone on the nighttime side of Earth sees that happening, a solar eclipse can only be seen by a very because the moon's shadow is so much smaller than the Earth's. So you will only be able to see the eclipse if you happen to be on the part of the Earth where the moon's shadow is going to fall and cover that area. So for this particular eclipse, this is the kind of path that the sun shadow is going to take. So you'll see it's really Antarctica is going to be the only place to see the total solar eclipse right here, which is where the moon's umbra, that's the darkest shadow, falls. And then around that, which is getting into the tip of South America and then kind of South Africa over here, they will be able to see a partial solar eclipse where only part of the sun is going to get covered. And that's, whoops, wrong way, that's the areas where the moon's penumbra falls. And that's the kind of partial shadow, which is exactly what we're going to see in that, a partial eclipse. So not for us, not for a lot of people. I do know that there are probably some people heading down to Antarctica to watch it. There are eclipse chasers who travel all over the world to see as many solar eclipses as they can. So if there does happen to be any sort of a live stream from anywhere that is seeing either the total or partial eclipse, we will be sure to share that on that day. But yeah, that's coming up in just a few days. Yes.
Looks like we have.
Yeah. Go ahead.
Do you get the question?
Mm-hmm.
Should I read it out then?
Yeah, go ahead.
Okay, yeah. So we do have a question. It's going to be, the sun and the moon also have to be aligned with the solar, with the solar plane?
Yes, which was actually the point I was just about to get to. So since the solar eclipse happens during a new moons happen, about once a month, but we only see solar eclipses maybe once or twice a year. And the reason for that is because you do have to have everything perfectly lined up. So most of the time, because the moon's orbit is tilted by about 5 degrees, most of the time during a new moon, the moon shadow is either going to fall above the Earth or below the Earth, and we won't get an eclipse. So this happens to be the perfect alignment between the sun, Earth, and moon, so that the shadow does fall on the Earth, and we do get that eclipse, that solar eclipse. And as I said, that happens maybe once to twice a year, depending on exact alignments. All right, so that is the first event coming up. The next one is going to be a little bit later in the month. On December 21st, we have the winter solstice. So Earth's rotation is tilted by about 23.5 to 23.4, depending on which book you're reading. So we're going to say about 23.5 degrees. So that means as we orbit around the sun, there are times in the year where the northern hemisphere is tilted towards the sun, and there are times in the year when the northern hemisphere is tilted away from the sun. And it's this effect that causes our seasons. So what's happening on December 21st, this was from a different year, which is why that date is wrong, and I only just caught that. On December 21st, we reach the point where we are most tilted away from the sun. And what that leads to is very indirect sunlight that gets spread out over a large area. And the sun does not get very high in the sky. All of that leads to less warming, and therefore we head into our cooler months and into our winter. So this date of the winter solstice is the start of winter here in the northern hemisphere. And because the sun is lowest in the sky on this day, that is the day that we have the shortest day and the longest night. Which does mean after the 21st, the days will start to get longer again, and these 4:30, 4 o'clock sunsets are going to start going away, because they're definitely getting to me a little bit. I don't think I'm alone in that either, but yeah, these long nights are interesting. Now, this is only for us here in the northern hemisphere. You can see in this diagram that when we are tilted away, the southern hemisphere is tilted towards. So while we're entering into winter, the southern hemisphere is entering into summer, and it is in fact their summer solstice. Okay, now let's take a look at some of the objects that we can see up in our sky. And we're going to start off with the moon. So the moon, of course, goes through a set of phases throughout the month. And so here are the 4 kind of main phases and when they will occur. So as we already know, December 4th is when we have our new moon. That's when our solar eclipse is going to happen. Then about a week after, on December 10th, we're going to have the first quarter. About a week after that, on December 18th, will be the full moon, which in the month of December is often called the oak moon or the cold moon. Cold moon makes sense because, it's December, we're heading into the start of winter. I wasn't quite able to figure out where the oak moon came from, though, but cold moon makes sense. And then about a week after that, December 26th, day after Christmas, we have the third quarter moon. So you have the dates here. I've also put when the moon is going to rise and set on these different phases, which does show kind of you can see the moon up at different times of the day, sometimes up during the day with the sun, sometimes up at night, depending on exactly what phase you're talking about. All right, well, let's take a look at what the planets are going to be doing. And we're going to start off in the morning sky. Just before sunrise, we have Mars peeking out above the horizon. So it should be visible pretty much all month. Come more and more visible and more easy to find as we go throughout the month, as Mars is slowly moving further and further away from the sun. But you'll be able to see it there kind of in the southeastern sky just before sunrise. All right, now looking out into our evening sky, we have quite a few planets visible just after sunset. We have Venus, Jupiter, and Saturn. Now, on the 3rd, which is coming up in just a couple days, Venus is actually going to reach its maximum brightness for this time when it's up in the evening. And so it's going to be incredibly bright, very easy to see. And this kind of maximum brightness comes from a combination of how much of Venus is illuminated and how close it is to us. Now you can see in this little insert here that if you were to look at Venus through a telescope or a pair of binoculars, you would actually not see the entire planet illuminated. Here on December 3rd, you're going to see kind of a crescent phase to it. And that happens because Venus is closer to the sun than we are. So because Venus orbits closer to the sun, we actually do watch it go through a set of phases, just like the moon goes through. Thank you, Quinn. And so we can see when it's kind of closer to us, we see it more in the crescent phase. And then when it's further kind of on the opposite side of the sun, we see it more in the gibbous phase. We never see it full because that's when it's opposite the sun from us and we can't see it when it's there. Fun fact, the fact that Venus goes through phases was actually one of the shreds of evidence that Galileo used to argue that the sun was the center of our solar system and not the Earth. Because if the Earth was the center, you would not see Venus go through phases, which tells us the sun must be the center of our solar system. See, we do have, is it just one question, or am I? Yeah. So.
Yeah, it looks like it's just that one question about the tilts. The tilting.
What are the tilts in the moon and the Earth in relation to? Oh, okay. And then what caused the tilts? Does this end? Good question. So I actually think I will come back and answer that one at the end because I have some things that I can pull up to kind of help show that and help that make sense. So I'll note we've seen it and I will answer it at the end after we get through this. All right. So that is kind of our evening sky just after sunset. We'll see Venus, Jupiter, and Saturn, and they will be visible all month long over here in the kind of south-southwest. And then joining them at the end of the month is Mercury, and that will become visible really right at the end of December. Now, if you do live at a lower latitude closer to the equator, you'll probably start to see it a little bit sooner than we will here up in Duluth, but definitely by the end of the month, it'll start coming through. And in fact, you can see that Mercury also goes through phases because just like Venus, it's closer to the sun than we are. And in fact, from these phases, we can tell, since Venus is in a crescent, that Venus must be on this side of the sun, the side closest to us, while Mercury in the nearly full must be on the opposite side of the sun from us. So those phases can actually help determine where exactly they are in their orbit, which is pretty cool. All right, now heading a little bit later into the night, we can also still see Uranus and Neptune up in the sky. Now, unfortunately, these are not visible to the naked eye. You do have to have a telescope to be able to see them. But with a telescope, you'll be able to make out the little circles of the planet. And depending on how good your telescope is, how big it is, you can also make out kind of a bluish color to the planets as well. And those will be visible up from whenever it gets dark So not just after sunset, a couple of hours after sunset, through till about midnight before they'll end up setting in the sky, or setting below the horizon. All right, and I believe that is up just about it for the planets. I had one more thing that I forgot about. Neptune is actually just about to end its retrograde motion. So generally, if you were to watch the planets against the background stars from night after night, you would see that usually the planets move very slowly eastward across the background stars. But every so often, the planets will reverse direction and start going westward. When that happens, that's what we call retrograde motion. And we now know that this happens as the Earth catches up and passes those planets, because Earth, being closer to the Sun, orbits faster than the planets that are further away from the Sun. In this case, this diagram is showing Mars, but this also works for Neptune as well. So this retrograde motion happens as we catch up and pass the planet. So at this point in time, we've kind of made our way past Neptune, and now it's going to start heading back in the direction that it should go, which is slowly eastward across the sky. And you can see here in this diagram, each of these little tiny retrograde loops that Neptune goes through as we catch up and pass it just about once a year. It's a little bit longer than a year, just about every year. Okay, now I think we're done with the planets. Let's move on to the next thing we have going on is a comet. We actually have a comet that's up in our sky right now, and this is Comet Leonard. It was actually discovered back at the beginning of the year on January 3rd by astronomer G.J. Leonard, and that's why it's named. It's named after the man who discovered it. These are a couple of pictures that have been taken of the comet, and during December, we are starting to get some pretty good views as it's finally making its way pretty close to the sun and its final kind of approach as it's going to get close to the sun and then swing around. And the reason it's getting much more visible now is because as it gets closer and closer to the sun, the ices that make up the comet start to vaporize. And that releases gas and dust, and light from the sun is able to bounce off of that, and it makes the comet appear much bigger and brighter. And as that stuff gets pushed back away from the comet, you also create these beautiful tails that we see on the comet. And usually you can see two tails, a gas tail and a dust tail. And so as Comet Leonard gets closer and closer to the sun throughout this month, it should shine brighter and brighter. Now, at the moment, it cannot be seen by the naked eye, but you can see it with a small telescope or even just a pair of binoculars. So the comet is moving pretty fast. So if you want to try and see it, here are a couple of different maps to kind of show you where you would need to look depending on what day you want to go out. So each of these is looking out towards the east about anywhere from an hour and a half to 30 minutes before sunrise. So it's starting off kind of in between the Big Dipper and Arcturus here, and it's slowly making its way down the sky. And so you can try and find it with, as I said, a small telescope or a pair of binoculars. The kind of best day that astronomers are estimating to view the comet is going to be on December 9th, around 5 a.m. local time. We think that this is going to be a really good combination of the approach to the sun, giving us a much brighter comet, but it's still going to be relatively high in the sky, because you can see throughout its approach, it's going to get lower and lower in the sky, closer and closer to the horizon as it's getting closer and closer to the sun. And that can make it difficult to see the closer it gets to the sun and the lower it gets in the horizon. So we think around December 9th is going to be the kind of best combination of bright but still pretty high in the sky. There are a couple of different estimates of how bright the comet is going to get, and most of them do suggest that it could get bright enough to see by the naked eye if you do have very dark skies. But there's still a little bit of uncertainty in exactly how bright and brilliant the comet is going to get, and we're really just going to have to kind of wait and see what happens. Now, if you do miss it at the beginning of the month in the early morning sky, you will have a chance about mid-month to check it out in the evening sky, where it will show up just above the kind of southwest right after sunset. So this is going to happen around December 14th. It'll switch from being in the morning sky to being in the evening sky. And then Comet Leonard will we will no longer be able to see it around Christmas time. It's going to get too close to the sun for us to see. It's going to make its closest approach to the sun on January 3rd, where the sun will then slingshot it out of our solar system. So this is your one and only chance to see Comet Leonard, because once it passes the sun is flinging it out of the solar system and it will never come back. And that is, unfortunately, the life of many comets and many things that get too close to the sun. All right. So next up after the comet, we have a couple of meteor showers happening this month too. I told you this month is loaded with lots of great astronomical events. So meteor showers typically happen when the Earth passes through the debris trail left behind by comets. And that debris falls through our atmosphere, heats up, and glows, and we get that trail of light that we call meteors, or sometimes shooting stars. Now, I said usually because we do have an exception this month. So the first meteor shower we're going to talk about, the first one happening this month, is the Geminids. Now this is a long-awaited meteor shower that people look forward to every year because it is one of the biggest and brightest and most spectacular meteor showers of the year. Now the Geminids are actually not caused by debris left behind by a comet. It's one of two major meteor showers that's actually the result of debris from an asteroid. And because it's debris from an asteroid, that debris is a little bit bigger and moving a little bit slower. That leads to much brighter, longer trailed meteors. And that's one of the things that make it such a spectacular show. Now, the other thing is the amount of debris. Geminids are looking at peaking around 120 meteors per hour during that peak night, which is going to be just amazing. So the Geminids typically run from about November 19th to December 24th. The peak is happening late on December 13th into the early morning of December 14th, with the best showing really being around 2 a.m. on December 14th. Now, at this time, we will still have the moon in the sky for about an hour, but after about 3 a.m., the moon will set and you will no longer have any interference from moonlight. So this looks like it's going to be a pretty good setup for the Geminids. Now, if to look for the Geminids, they're named so because they appear to come from the constellation of Gemini. So they'll be kind of coming from this direction, which at this time is going to be kind of up in the south. But usually you don't actually want to look directly in the south. You want to look more towards the southeast or the southwest, or even just east and west. And then you'll see the trail as it's coming by, and it'll have kind of a longer trail, and it's going to be easier to see those. So that's what you want to kind of look for. But honestly, you can see them anywhere in the sky. Now you will notice that there are a couple of other meteor showers happening at this time as well. These three are all very minor showers with like 1 to 2 meteors per hour. So really nothing exciting, especially not compared to the beautiful Geminids. Now, not long after that, we do have our second, not minor, but it's not as spectacular as the Geminids. We have the Ursets peaking the night of December 21st into the early morning of December 22nd. This is a meteor shower associated with Comet Tuttle, and we're looking at 5 to 10 meteors per hour. So a moderate meteor shower. And this one appears to originate from around the Little Dipper. And so that's going to be kind of in the north. So you're going to look more kind of east and west again to see those trails from those from those meteors. Okay. Next up, let's take a look at the International Space Station. Because for those of us in Duluth, we are going to have some decent showings of the International Space Station this month. So this is from a website that if you've been to any of our What's Up shows, you've heard me talk about before. This is heavens-above.com, where you can put in your location, click the little ISS button, and it'll tell you exactly what's in your sky. So for those of us here in Duluth, you can see at the beginning of the month, we have quite a few evening showings. What you want to look for when trying to find a good time to go out and look for the ISS is the time that it's happening. And then you also want to look at the brightness. Now this is in magnitude, which is a little bit tricky for some people because it's actually opposite what you think. The smaller the number, the brighter it is. So if you want a really good showing of the ISS, you want to look for the smallest number, which in this set is going to be happening here on December 3rd at 5:57 p.m., where we're going to have a negative 3.8 magnitude, so very bright. Now, the great thing with this is if you were to click on that date, it would then take you to a page where it'll show you the map of where you can see the ISS in the sky and exactly what time it'll be in those positions so that you could get all set up and ready to see. Now again, for anyone not in Duluth, you can do this for yourself by going to this website. It's also linked in the video description below, and put in your location and find your ISS passovers. Okay, last thing to talk about is a really awesome event that's happening up at Grand Marais. This is the Dark Sky Festival. It's kind of the sister event to our Dark Sky Caravan that happens in the summer. This year, the Dark Sky Festival is happening from December 9th to 11th. There are a lot of really fun and awesome things going on up in Grand Marais. I've put the link to the event in the video description so you can see the full schedule for this entire weekend. We will be going up on December 10th, where we'll be set up at the Voyager Brewing with telescopes and fun activities and things to do some telescope viewing, live star shows, and things like that. So you can come see us on December 10th and then also check out the rest of the other events going on as well. Again, information at the link in the video description. All right, and I think that's it. I think this is the first What's Up that I have legit, actually, it's taken half an hour. There was a lot going on this month. Okay, now I want to get back and answer that question. That was asking about the tilts of everything. So let me very quickly pull up a graphic. Okay. I think this is going to be a good one. And if anyone else has any other questions, now is a good time